Bismillahirrahmanirrahim. Let us continue with 4.4 intermolecular forces. Please read the objectives. What is intermolecular forces? It is an attractive forces that exists between molecules, which it is much weaker than covalent bonds. The strength of intermolecular forces will determine the physical properties such as the melting point, boiling point, and the solubility. What is solubility? Solubility is keterlarutan. There are two types of intermolecular forces, which are van der Waals forces and hydrogen bond. So, types of intermolecular forces is classified into two, van der Waals forces and also hydrogen bond. Then, bawah van der Waals forces, kita ada apa? Kita ada dipole-dipole forces, which this exists between the polar molecules, while London dispersion forces exists between the non-polar molecules. It is actually exists for both polar and non-polar. But for polar molecules, we will highlight on the dipole-dipole forces. Dipole-dipole forces which exist between neutral polar molecules. It is an attractive forces that exists between these neutral polar molecules. So HCl is an example of a polar molecule, a neutral polar molecule. We know that chlorine is more electronegative than hydrogen, right? Which the arrow is pointing from a less electronegative, which is hydrogen, to a more electronegative, which is chlorine. So why we have this partial negative? Because chlorine is more electronegative than hydrogen. So hydrogen will be partial positive, which means less electronegative. So here, what happened? The positive end, which is the partial positive here, of this HCl molecule will attract the negative and partial negative here of the dipole of the other molecule. So the forces effective only when both polar molecules are very close together. So it will become significant when they are very close together. Ingat nak? Katakanlah satu HCl duduk kat sini and the other HCl duduk sini. Macam mana nak interact? Jauh sangat. So, they must be very close. Then only the forces will become significant. Okay? How about this bond? What is this bond? Within the same molecule, it is covalent bond. Within the same molecule, it is covalent bond. Why this is covalent bond? Because they share the electron. This hydrogen share the electron with this chlorine. So, it is covalent bond. Kalau HCl ini is the covalent bond. Right. If H and Cl from two different molecules, then only it is called as dipole-dipole forces. So, it is one type of interaction. The attractive force that exists between the partial positive and partial negative from two different molecule. So, H ini attracted to this Cl from the other molecule. Itulah kita panggil dipole-dipole forces. If it is within the same molecule, it is referred as covalent bond. Why? Because they share the electrons. The strength of dipole-dipole interactions will depend on its molecular polarity. The higher the polarity of a molecule, the higher the dipole moment. Then, what happened to the dipole-dipole attraction? It will be stronger attraction. As a result, the boiling point will be higher as well. So, dipole-dipole forces will depend on the difference of electronegativity or the shape or the dipole moment. For instance, here we have CH3CN. We know that nitrogen is one of the most electronegative atom. Right? So, N adalah salah satu yang the most electronegative atom. Remember phone? Right. So, nitrogen is one of the most electronegative atom. That's why it has high difference of electronegativity, which is 3.9 instead of ether. So this is ether. COC, kalau you tengok ada COC, this is ether. Okay, ether, the difference is 1.3. The difference of electronegativity is 1.3. How about the boiling point? Boiling point for CH3CN will be higher, which is 81.6 degrees Celsius. Instead of ether is only negative 25. Why? Because CH3CN is a polar molecule with dipole-dipole forces, while ether is a non-polar molecule with only weak van der Waals forces, or it has only London dispersion forces. Okay, next is London forces or London dispersion forces. It is an attractive forces that exists between atoms or non-polar molecules. It is a temporary dipole only. Temporary. Bersifat sementara. Instead of dipole-dipole forces tadi, it is a permanent dipole yang kekal. Kenapa ini kekal? Because Cl is more electronegative than Cl. Right, the electron cloud of chlorine would be bigger than hydrogen, which electron is attracted towards chlorine since chlorine is more electronegative than hydrogen. Permanent lah, sebab chlorine memang more electronegative than hydrogen. How about I2 or O2 or Cl2? They are the same atoms, right? So the same atom will have the same electronegativity. For instance, we have here is Cl2 molecule. So Cl2 is a nonpolar molecule. Why is it nonpolar molecule? Because they are the same atoms, right? Chlorine and chlorine the same atom, so of course they have the same electronegativity. So Cl2 molecule has even distribution of electrons, or we said the density of electron is on average symmetrical. Means mulanya dia punya electron cloud tu lebih kurang sama besar. Kenapa lebih kurang sama besar? Yalah, the same atom got the same electronegativity. Tarik sama kuat, tarik elektron sama kuat, right? Because they have the same electronegativity. So of course the electron cloud is at the average symmetrical. Lebih kurang sama besar je dia punya electron cloud. So Cl2 is said to be having even distribution of electrons. Lebih kurang sama, kan? Yet at any instance the electron distribution pun may be unsymmetrical, can be unsymmetrical. So bila lah pula dia nak jadi unsymmetry ni? Daripada simetri jadi simetri. Bila? Okay, bila tau? Bila very close together. Bila dia dekat ataupun rapat. If let's say we have the other Cl2 molecule very close with the first Cl2 molecule just now. We know that chlorine has its electron cloud, right? Ni chlorine dia ada electron cloud dia. Chlorine ni pun ada, chlorine ni pun ada, right? Dan kita tahu tadi it is at average symmetrical electron density, right? So what happen when they are very close together? Electron and electron has repulsion. Electrons will repel one another. Then what happen to the electron cloud? It will be pushed towards the other chlorine. This one pun push towards this chlorine, kan? Itu yang kita ada apa tau? Tadi electron cloud dia sama besar, tapi sekarang dia jadi kecil sikit. Dia jadi kecil. So one side has a smaller size and the other side got bigger size sebab dia dah tertolak ke sana. Yang ni pun tertolak ke kanan. Right, so tadi sama besar je. Right, sekarang dia jadi besar sebelah, kecil sebelah. So dia jadi kecil sini, besar sebelah sana. Sebab electron cloud dah tertolak sesama sendiri. Right, so Itu yang kita kata tu, electrons are unevenly distributed. Dah tak sama besar. Kan, maybe higher at one terminal than the other. Why? Because this is due to the electron's repulsion. The movement of electrons in one atom can induce, boleh mempengaruhi, the movement of electrons of its neighbor atom, lead to a small instantaneous dipole. So, dia akan jadi dipole yang sementara. Dia bukan permanent tau. Dia sementara sahaja. Instantaneous dipole, or is what we call temporary dipole, yang tidak kekal. So, itu yang kita ada. Bila dia tertolak, dia jadi kecil sebelah, besar sebelah. Then, what happen here? Yang kecil sebelah itu will be partial positive and the bigger electron cloud will be partial negative. Then, dia jumpa pula dengan the other Cl2 molecule yang lain having the same condition. Pun sama lah. Sebelah besar, sini, sebelah is bigger size, sebelah sini smaller size. Then, dekat. Duduk dekat. Kan? Bila duduk dekat. Ni duduk dekat. Kat mana London forces tu? London forces is when the partial positive ini, the partial positive end jumpa rapat dekat dengan the partial negative end tu. Kan? Yang electron cloud yang kecil ini jumpa dengan yang besar kat sini. So, interaction itulah yang kita panggil London dispersion forces that exist between non-polar molecules. Then, the instantaneous dipole will induce a dipole on the neighboring atom. Dia boleh mempengaruhi dipole jiran sebelahnya. So, the force of attraction that exists between the instantaneous dipole and the induced dipole, itulah yang kita panggil London forces. When they attracted to each other, the negative end jumpa dengan the positive end, then only London forces will become significant. Syarat dia mesti rapat dan dekat. Sama macam dipole-dipole forces tadi. Kalau jauh, satu Cl2 duduk kat sini, satu lagi duduk sini. Bila dah jauh, macam mana nak interact? Kan? It's not significant. So, mesti rapat dan dekat. Positif jumpa negatif terminal, then only it becomes significant. Barulah ada attractive forces, which is London dispersion forces. Let us look at the tutorial question, which it is asking you to explain how London forces arise between non-polar molecules. So, you are given Cl2 molecule. London forces are significant only when it becomes significant again when they are very close together. So, when Cl2 jumpa with the other Cl2 molecule, kan, which means we have the interaction is between the partial negative, the negative end jumpa with the partial positive end, kan, like this, then only they become significant, having the interaction between the negative end with the positive end. What is the type of attractive forces exist is London forces here. How about if it is within the same molecule? Is what we call covalent bond. If it is between two different Cl2 molecules, then it is called as London dispersion forces. At any instant, the electron distribution in the molecule may be asymmetrical. Boleh jadi tak sama besar lah. Tak simetri lah kan. Sebelah besar, sebelah kecil. Giving it a temporary dipole. Due to the electron repulsion just now, right, the motion of electrons in one atom can influence or can induce the motion of the electron of its neighbor atom. Thus, the temporary dipole of one atom of course can induce the similar dipole of the adjacent atom. So, dia bolehlah mempengaruhi dipole yang sama pada atom yang bersebelahan, causing the atoms to be attracted to each other. This is called the London dispersion forces. Let us look at the factors that can affect the van der Waals forces. There are three factors which can affect the van der Waals forces, which are molecular size, molecular shape, and polarity. Let us start with molecular size first. For instance, we have S8, sulfur 8. How about the size? Is bigger size than P4, of course, with higher molar mass. Bigger size is like a crown here, right? Okay, bigger size, bigger contact surface area. So the size of S8 molecules is bigger than P4 molecules. The larger the molecular size, the polarizability becomes greater. Consequently, the van der Waals forces will become stronger. Let us look at the point. Larger molecular size having higher molar mass. Right, okay. Then, how about the contact surface area? Of course, got the larger contact surface area. Down a group. For instance, we have group 17. Fluorine, chlorine, bromine, iodine. The smallest one is fluorine. Fluorine paling kecil. Chlorine besar sikit. Bromine lebih besar. Iodine paling besar. Right. So down a group, what happened to the size? Is bigger size. Right. How about the number of electrons? Of course increases. Atomic radius increases as well. How about the outer electrons? Are farther from the nucleus. Mestilah tertolak lebih jauh. Because the nucleus has weaker attraction towards the valence electron. Right. How about the electron distribution? The electron distribution or the electron cloud will become more easily distorted. Lebih senang terherot. Sebab saiz yang besar susah tarik. Right. Weaker attraction. Or it is said to be easier to be polarized as the outer electrons are less tightly held by the nuclei. The more electrons, the more distance over which they can move. The bigger the possibility to be polarized. The greater polarizability lah tu. Consequently, the London dispersion forces will become greater. Okay. Kat sini, as the molar mass is high, the size will be bigger as well. The same goes to the contact surface area will get larger, then easier to be polarized. Therefore, van der Waals forces become stronger. How can that molecular size affect the boiling point? The larger molecular size, the stronger van der Waals forces. Thus, we need more energy to overcome the attractive forces between the molecules. As a result, the higher its boiling point. Let us refer to this table. We have F2, Cl2, Br2, and I2. This is descending down group 17. Look at the molecular weight. It is increasing from F2 to Cl2, from Cl2 to Br2, from Br2 to I2. So descending down a group, the molecular weight of course will be increased. How about the boiling point? Will be increased as well. Why? Because the higher the molar mass, got bigger size, bigger contact surface area, stronger van der Waals forces. Then what happened to the boiling point? Boiling point will be increased as well. Next factor is molecular shape. Let us look at the example. We have here pentane. Pentane means we have 5 carbon. How about 2,2-dimethylpropane? Also 5 carbon. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So both of these molecules got the same molar mass with the same formula, which is C5H12. Right. Okay, when we refer to the molar mass of C5H12, the same molar mass must have the same boiling point. Right. But why they have the different boiling point? This is due to the molecular shape. Okay, pentane has linear shape or straight chain structure, straight chain molecule. Linear molecule will have larger contact surface area with stronger van der Waals forces. But when we compare between a linear shape, linear or straight chain, with planar molecule, what is the example of planar molecule? Is benzene. Benzene is the example of a planar molecule. C6H6. H6, benzene. Right. So each C got 1 H. Okay, understood is there, but it's hidden. Benzene is an example of a planar molecule having the biggest contact surface area instead of a straight chain. Hexane or pentane. Okay, how about branching molecule? Example is here we have 2,2-dimethyl-propane. So when we have branching molecule, this will reduce its surface area. It become more compact or more spherical. Reduce its contact surface area with weaker van der Waals forces. Okay, but when we compare with these two, pentane is a straight chain molecule or linear molecule, while 2,2-dimethyl-propane has branching structure. Pentane has a larger contact surface area with stronger van der Waals forces. So more energy is needed to break the forces. Hence, it has higher boiling point. Let us look at the last factor, which is polarity. Polar molecules will have higher boiling point compared to non-polar molecules. What type of forces in polar molecules? It is dipole-dipole forces. Right. How about non-polar molecules? Non-polar molecules have London dispersion forces. Have an example why the boiling point of ICl is higher than Br2. ICl is a polar molecule. Why ICl is a polar molecule? Because Cl is more electronegative than iodine. How about Br2? Br2 is a non-polar molecule. The same atom, bromine and bromine, have the same electronegativity. So, it is a non-polar molecule. What type of forces exist in polar molecule? It is dipole-dipole forces, while Br2 as the non-polar molecule has only weak van der Waals forces. Then you state dipole-dipole forces is of course stronger than the London dispersion forces. London dispersion forces is one type of van der Waals forces. So the stronger the type of forces, the higher the boiling point because more energy needed to break the forces. How many factors you have learned? Number 1 is the molecular size. Then the shape. Right. Then the last factor is polarity. Why the boiling point of ICl is higher than Br2? Look at the molar mass of ICl. What is the molar mass of ICl? Molar mass of ICl is 162.35. How about the molar mass for Br2? Br2 is 159.8. So, bila kita tengok di sini, the molar mass has no significant difference. One is 162. The other is 160 after we round off. Right. So, beza molar mass tidak tinggi pun, 162 and 160. Makanya, we cannot discuss in term of size. Because when we compare the molar mass, 162 and 160 has no significant difference. So, you cannot discuss in term of size. Because if you want to compare the term of size, make sure the molar mass has significant difference. Beza molar mass kena tinggi, then only senang you nak explain. Then, how about the shape? Bergerak kepada point shape. Why cannot we discuss in term of shape? Because both ICl and Br2 are simple molecule. It is a linear molecule. That's why you have to move to term polarity. Because clearly Cl is more electronegative than iodine. while Br2 is a non-polar molecule. Right. Okay, so you boleh compare in term of polarity, which ICl is a polar molecule, Br2 is a non-polar molecule. We know that polar molecule ada apa? Dipole-dipole forces, while non-polar ada apa? London dispersion forces. Dipole-dipole forces is stronger than the London dispersion forces, hence it has higher boiling point. Sebab apa? Kalau you compare in term of size, kan, kita akan kata bila molar mass dia sama, ada saiz yang lebih kurang sama, right, a linear, kan, a linear. So bila molar mass lebih kurang sama saja, 162 and 160, then kita akan conclude boiling point akan jadi sama je, tetapi tidak. Why? Because this is due to the difference of forces that exist between polar molecule and also the non-polar molecules. Makanya ambil point mana? Ambil point polarity. The other example of factor polarity, both ethane and fluoromethane having almost the same molar mass. For ethane, molar mass is 30, while fluoromethane, the molar mass is 34. Right? So when we look at the molar mass is almost the same, 30 and 34, has no significant difference, we will expect in the first place the boiling point will be the same or almost the same. But here we can see that fluoromethane has higher boiling point than ethane. Why? Because this is due to the difference of type of forces that exist between their molecules. So tengok dekat first point, both molecules have almost similar molecular mass. So boleh tak kita discuss in term of molar mass with bigger size? Boleh discuss in term of size? No, tak boleh. Why? Because they almost have the same molar mass. Lebih baiklah kita discuss in term of polarity. Why? Because we know that fluorine is the most electronegative atom. So, fluoromethane ada apa? Fluoromethane got dipole-dipole forces between their molecules, wajib tulis. Between their molecules, wajib tulis. While C2H6, the hydrocarbon having two carbon ini, has only weak London dispersion forces. Therefore, fluoromethane will have higher boiling point than ethane. Hydrogen bond. Hydrogen bond is the electrostatic attraction between hydrogen that bonded direct with phone, either it is fluorine, oxygen or nitrogen of one molecule, with hydrogen that bonded to phone also. What is the bond within this molecule? Is covalent bond. Why is it covalent bond? Because they share the electron. How about the attraction that exists between this partial positive end and this negative end? Then only it is called hydrogen bond. If it is within the same molecule like this, then it is covalent bond. Why is it covalent bond? Because they share their electron. H and F share the electron, so it is a covalent bond. So hydrogen bond is the strong permanent dipole-dipole attraction. If we compare hydrogen bond, dipole-dipole forces and London dispersion forces, the strongest bond is hydrogen bond. So the type of intermolecular forces, the strongest one is hydrogen bond, followed with dipole-dipole forces, and the weakest intermolecular forces that exist between the molecules is London dispersion forces. Let us look at next example of hydrogen bond, which is water molecule. The H atom of water molecule is attracted to the neighboring molecule due to the electrostatic attraction that exists between the partial positive charge on the H atom of this water molecule and the partial negative charge on the other water molecule. So that is the hydrogen bond. How about this bond? OH within the same molecule is the covalent bond. Why covalent bond? Because they share the electron. If it is from two different molecules, when this H attracting with this oxygen from the other two water molecule is the hydrogen bond. Again, what is the condition to have hydrogen bond? A molecule must have H atom, such as HF, hydrogen fluoride. HF has H atom, which H atom bonded to one of the most electronegative atom, which is fluorine. The neighboring molecule also is H with phone, right? For instance, we have HF. So, if it is within the same molecule, is the covalent bond. If it is the attraction between the partial positive with a partial negative from two different molecules, is the hydrogen bond. Ammonia. How about ammonia? Does ammonia have H atom? Yes, ammonia has H atom. Which H atom bonded to F or O or N? Yes, NH, NH. So when the attraction is between the partial negative of this nitrogen attracting with this partial positive hydrogen from the other ammonia molecule, that is the hydrogen bond. So it is the formation of hydrogen bond between the ammonia molecules. Attraction that exists between the partial positive charge of H atom and the lone pair electrons of nitrogen of the other ammonia molecule, that is the hydrogen bond. Therefore, on the average, each ammonia molecule can form one hydrogen bond. Again, what are the conditions to have hydrogen bond? One molecule must have hydrogen atom that bonded covalently to a very electronegative atom such as fluorine, oxygen, or nitrogen. And its neighbor molecule also must have H with phone. Note here, hydrogen bond is about 5 to 10 times stronger than dipole-dipole attractions. So hydrogen bond is stronger than other dipole-dipole attractions. What are the factors that affecting the strength of hydrogen bond? If we compare water molecule with ammonia, hydrogen bond of water is more than ammonia molecule. Therefore, the boiling point of water is of course higher than ammonia. Why? Because water can form more hydrogen bond between the molecules. Next factor that affecting the strength of hydrogen bond is the electronegativity. We know that fluorine is the most electronegative, followed with oxygen and nitrogen. As a result, the hydrogen bond of HF will be higher than ammonia. Why? Because this is due to the higher electronegativity of F compared to nitrogen. Next is an example of ether. No hydrogen bond is formed between ether molecules. Why? Because no hydrogen atom is covalently bonded to a highly electronegative oxygen atom. What is the condition to form hydrogen bond? Remember, hydrogen bond form when molecules contain H with F or H with O or H with N. Right? How about this ether? Ether is COC. Since ether has O that directly bonded to carbon, therefore ether has no hydrogen bond. It has only weak van der Waals forces that exist between the molecules. As a result, ether will have lower boiling point. Let's have question from Camfran, question number 35B. You are given methane. The molar mass of methane is 16 gram per mole, while propane is 44. Since molar mass of propane is higher, so propane must have bigger size with bigger contact surface area, stronger van der Waals forces between their molecules. So between their molecules, wajib tulis. Ingat between their molecules, wajib tulis. So what to do is to you state that both methane and propane can form London forces. Why London forces? Because they both are non-polar molecule, which propane has higher molar mass with bigger molecular size. Thus, it has larger contact surface area compared to methane. As a result, the intermolecular forces of propane is stronger than methane, whereas water has higher boiling point than hydrogen sulfide. Hydrogen sulfide, the molar mass given is 34, whereas water is 18. Logicnya, when we have higher molar mass, must have bigger size, bigger contact surface area and so on, right? But why water with lower molar mass has higher boiling point pula? Right, okay. So here, what can you relate is to relate water with the existence of hydrogen bond. Here, water form hydrogen bond between their molecules. So, ingat, between their molecules, wajib tulis. Whereas H2S forms dipole-dipole forces. Hydrogen sulfide is a polar molecule. So, what type of intermolecular forces that exist between polar molecules? It is dipole-dipole forces, which we know that hydrogen bond is much stronger than dipole-dipole forces. As a result, water will have higher boiling point instead of hydrogen sulfide. Next, let's look at the effect of hydrogen bond on boiling point. Oxygen is from group 16, the green color. Fluorine is from group 17, the red color. Group 15 is nitrogen, the blue color, this blue, while carbon is from group 14, the purple one. From this graph, we can see that clearly water, HF, and ammonia have extremely higher boiling point than others in the same group. Why? Because they have hydrogen bonds between their molecules. Water. Why water has the highest boiling point? Which we know that water boils at 100 degrees Celsius because water can form the highest number of hydrogen bond instead of HF and ammonia. That's why water has the highest boiling point if we compare to the others. Next, let us look at this question, which you have to explain the trend of boiling point descending down group 14. Group 14, which consists of carbon, silicon, germanium, and sternum. So here, the boiling point, we can see that it is increases from CH4 to SNH4. As the molar mass or molecular size increases from carbon to sternum, the van der Waals forces also become stronger. More energy needed to overcome the van der Waals forces. They are all simple molecular structure. So as the molar mass is increasing from carbon to silicon to germanium to sternum, we can see the boiling point, the trend is also increasing as the increasing of van der Waals forces. We have done group 14 just now. Now let us look at group 15. Group 15, we have nitrogen, phosphorus, astatine, and antimony. So why the boiling point of ammonia is relatively higher than pH 3? This is due to the existence of hydrogen bond that exists between that ammonia molecules, while the rest have only weak van der Waals forces, which we know that hydrogen bond is stronger than the van der Waals forces. Therefore, of course, we need more energy to break the strong hydrogen bond, thus higher boiling point for ammonia. When we refer to phone, which we know that the electronegativity of F is higher than oxygen. F is the highest electronegativity when we compare to oxygen, which is less electronegative than F, while nitrogen is less electronegative than oxygen and fluorine. Right, so even the electronegativity difference between HF, which means fluorine is more electronegative than oxygen, then we will expect HF will have higher boiling point than water. But water has higher boiling point than HF. Why? Because per one water molecule can form up to 4 hydrogen bond. Instead of fluorine in HF can form less hydrogen bond between their molecules. That's why water has the strongest hydrogen bond. While nitrogen for this ammonia molecule We know that nitrogen has the lowest electronegativity, thus hydrogen bond between ammonia molecules will be the weakest. As a result, ammonia will have the lowest boiling point. How about to explain the boiling point of methane, ammonia, HF, and water? We know that these three molecules got hydrogen bond between their molecules, right? Because it has OH bond, HF, and NH, right? How about methane? Methane has no hydrogen bond. It has only weak van der Waals forces between their molecules. We know that hydrogen bond is stronger than the van der Waals forces. Therefore, the boiling point of methane is the lowest, while the rest of water, HF, and ammonia will be higher boiling point instead of methane. But why water is on the top or the highest boiling point? Because water can form the highest number of hydrogen bond between their molecules. That's why water has the highest boiling point. How about HF and ammonia? Why HF has relatively higher boiling point than ammonia? Because this is due to the electronegativity of fluorine, which is more electronegative than nitrogen. Therefore, boiling point of HF is higher than boiling point of ammonia, while water higher boiling point than HF because water can form the highest number of hydrogen bond between the water molecule. Let us look at next example, which you have to arrange the boiling point of ammonia, BH3, BH3, and ammonium chloride in ascending order of boiling point. We will look at ammonium chloride first, which ammonium chloride has ammonium ion NH4 plus and also chloride ion. So when we have the positively charged and negatively charged ion attracted to each other, what is the type of compound? It is an ionic compound, which it is held by ionic bond. The particles are held between the positively charged cation and anion. How about ammonia? Ammonia has NH bond with NH bond, right? So what type of bond exists? It's hydrogen bond. It is a simple covalent molecule, which is a polar molecule. How about BH3? BH3 also is a simple covalent molecule, and it is a polar molecule. It has London dispersion forces and dipole-dipole forces. How about BH3? It is also a simple covalent molecule, but it is a non-polar molecule because it is a symmetrical molecule. So what type of interparticle forces exist in that BH3 molecule? It is London dispersion forces. So how can you arrange the boiling point in ascending order? The highest boiling point is ammonium chloride, followed with ammonia because ammonia has hydrogen bonding. BH3 has dipole-dipole forces, while BH3 has the lowest boiling point because it has no hydrogen bond. It is a symmetrical molecule with London dispersion forces. Or you can state it has van der Waals forces. BH3 has dipole-dipole forces because it is a polar molecule. How about NH3? NH3 has hydrogen bond, while ionic bond is the strongest. The stronger the attraction between the particles, of course we need more energy to overcome the strong attraction between the particles. So ammonium chloride will have highest boiling point. Why? Because the interparticle force between the ammonium cation with chloride ion is the ionic bond. So they have very strong attraction of ionic bond. Therefore, it has the highest boiling point. How about ammonia? Ammonia has hydrogen bond. We know that hydrogen bond is stronger than dipole-dipole forces in BH3. That's why NH3 has higher boiling point than BH3. How about BH3 and BH3? BH3 is a non-polar molecule, while BH3 is a polar molecule. What type of forces that exist between polar molecules? It is dipole-dipole forces. How about BH3? BH3 is a non-polar molecule with London dispersion forces. So BH3 of course will have higher boiling point than BH3 because it has dipole-dipole forces which is much stronger than London dispersion forces. Let us look at how hydrogen bond can affect the solubility. Solubility means keterlarutan. Water. Water, is it polar or non-polar molecule? Water is a polar molecule. So water is a good solvent for polar molecules. Why? Because water itself is a polar molecule. So ammonia and HF are soluble in water. Why? Because they both can form hydrogen bond with water molecule. Most organic compounds are actually insoluble in water. Why? Because they cannot form any hydrogen bond with water molecule except for amines, alcohols, and carboxylic acid. They are soluble in water. Why? Because these compounds can form hydrogen bond with water molecule. So remember, any compound that can form hydrogen bond with water molecule, they are soluble in water. Such as this amine molecule, this is methanamine. Methanamine can form hydrogen bond with water molecule. Why? Because methanamine has NH while water molecule has OH. So there is an attractive forces that exists between hydrogen, which is partial positive, with nitrogen from amine, which is partial negative. So this interaction is what we call hydrogen bond. The same goes with carboxylic acid. This is carboxylic acid. Ethanoic acid. This is ethanoic acid. At means got 2 carbon. This 1 and 2 carbon. So ethanoic acid is soluble in water because it itself has OH bond. Water also got OH bond, right? So oxygen is partial negative attracted to this hydrogen of the water molecule, which is partial positive. So what type of interaction is this? This is hydrogen bond. Does ammonia soluble in water? Yes, it does soluble in water because it can form hydrogen bond with water molecules. Ammonia has N and H, which are covalently bonded, while water has OH bond, covalently bonded. So the interaction between this partial positive charge from water molecule with nitrogen, which is partial negative from the ammonia molecule, is the hydrogen bond. So remember, the solubility of one substance is greatly dependent on the ability of forming strong hydrogen bond or having dipole-dipole interactions between the solute and the solvent particles. Any compound that can form hydrogen bond with water molecule is said can be dissolved readily in water. Compounds that can form hydrogen bond with water molecules are more soluble than those do not. For instance, we have is methanol. Methanol is one type of alcohol with 1 carbon, CH3OH. So methanol is soluble in water. Why? Because methanol can form hydrogen bond with water molecule. Solute is the methanol while solvent is the water. So remember, polar solute is soluble in polar solvent because they have intermolecular forces which is either dipole-dipole forces or hydrogen bond. While non-polar solute can be dissolved in non-polar solvent, having the interaction is the London dispersion forces. Next example is sodium chloride. Sodium chloride is an ionic compound. It is polar solute. Why polar solute? Because it is held by the positively charged and negatively charged ion, right? So it is soluble in water. Why? Because water is a polar solvent. Next example is butane. Butane is a nonpolar solute. It is dissolved readily in benzene, C6H6. Butane is C4H10. So, butane is dissolved readily in benzene because they can form intermolecular forces, which is London dispersion forces of the van der Waals forces between butane and benzene. Solute is butane, while benzene is a solvent. Next, let us look at the effect of hydrogen bond on density. Question: why water liquid is denser than ice, which is water in solid state? Or why does ice float? For ice, each water molecule is rigidly bonded to the other 4 water molecules. One water molecule is rigidly bonded to the other 4 water molecules. So this is the structure for ice, which each water molecule is rigidly bonded to the other 4 water molecules by hydrogen bond in the form of tetrahedral. This is a hydrogen bond. This is also the hydrogen bond. Where is the empty spaces? Here is the empty spaces. So when they arrange themselves in this tetrahedral arrangement, this tetrahedral arrangement will give rise to an open structure with many empty spaces between the molecules, and also will lead to a bigger volume. Here, got bigger volume here. This is the open structure with bigger volume here. We know that density is equal to the mass per volume. So what happens when volume is high or bigger volume? Density will be low. So when ice melt, what happens? Some of the hydrogen will break. When ice melt, some of this hydrogen bond will break. The open structure just now will collapse. So this open structure will collapse. Water molecules become more compact, causing the volume to be decreased. So when volume is decreased, what happens to the density? Of course, density will be increased. That's why ice float in water.